Hi, Year 11. Today I'm just going to do a very quick lesson on variation, selective breeding and evolution. There's a lot of information in this lesson, so I thought it's best that I talk you through it. I won't take more than 10-15 minutes. Now, make sure you've got this open. This has got everything on anyway, so if you're happy to just read through it, that's fine, but I'm going to go through some very specific examples at the end, and I'll try and timestamp it for you. So if you're happy to read through it by yourself, you can skip to my examples where I tell you exactly how to answer each question every single time. Now, this is your title slide. If you want to read through it, pause the video. If not, it's getting minimized. Now, we know about variation. We did this before. So this top box here, we've talked about genetic variation, we've talked about environmental variation, we've talked about the different types, for example, eye colour, height, hair colour. So I'm going to skim over that, and I'm going to move straight on to selective breeding. Now, if you take a look at this, and then this, these are two different breeds of cow. They will have originated from the same breed at some point very, very long time ago, but we bred them for different things. This one on the left here, this is a milk cow. Okay, this one on the right, this one's for meat. And you can quite clearly see the difference, apart from the fact one's a boy and one's a girl. The udders on here, compared to other female cows, will be much bigger. They will produce a lot more milk. And she's quite skinny. You see her, you can see her ribs. She's not very fat, okay? She's not got very much muscle. This one, on the other hand, you can see it very well built. You can see pretty much every single muscle on its body, because this cow is for meat. So this is one example of how we have selectively bred two different species from the same ancestor. Now, the whole point about selective breeding, okay, one, decide the characteristics that are important, choose those parents that have those characteristics. So for example, let's say you would like a cow like this. You find the biggest, muscliest mum and dad possible, and you force them to breed together. After they have children, you get the biggest, muscliest children, and eventually when they grow up, start breeding them together as well, preferably with different animals so they don't get inbred. But if you've got nothing else, you'll just inbreed them. It doesn't really matter if they're just going for meat. Then you choose after you've chosen the offspring and you've chosen who you're breeding them with again, you repeat this and repeat this and repeat this. It might take 10 goes, it might take 50 goes, so it takes a long time. Eventually you end up with a cow that looks like what you need. Okay. Now let's say I was going to breed for a white bull. Okay, so this muscly one. And I had a question that said, describe the process that to selective breed a white bull. Okay. Now, first thing, choose the parents that have the most meat. Okay. After you've done that, you make them breed. After that, you choose the offspring or children that have the most meat. Then breed them, then repeat. This in itself, it's pretty much a 6-mark answer, and it's always exactly the same. If I wanted to do it for the female cow here, you would say choose the parents that have the most milk. In the case of milk cows, obviously the female produces the milk, so maybe you choose the female that has the most milk, and you choose the male, okay, that mother had the most milk, or its sister had the most milk, because they must have those genes somewhere. Again, make them breed. Choose the offspring that produce the most milk. Make them breed. Repeat. This answer is always going to be the same, and it's easy for 6 marks. So, the next one we're going to move on to Natural selection. So the idea of natural selection or evolution is species evolve because of natural selection. So the reason why we are like this now, billions and millions of years ago we were Neanderthals and we changed. Billions of years before that we were bacteria. Okay. Generally what happens is, if you have got a trait that is better than the people around you, so for example, you're slightly stronger, you're more likely to be able to get food, you're more likely to survive, and then you are more likely to reproduce. And when you reproduce, you pass those genes on. So let's say plants. You've got a plant that is slightly taller than the other ones. That plant will get more sunlight, it will grow bigger, it's more likely to survive, so then it will pass those beneficial traits on to its babies. Now let's have a look at this. Here we've got a desert fox and we've got a winter fox. They came from the same ancestor. Now if you look here, the desert fox, it lives in snowy area, and the desert fox lives in the desert obviously, and this winter fox, the Arctic fox, lives in a snowy area. So you can also see the differences between the two. Look, massive ears. One, to hear predators or prey. Two, to lose heat. It's got a very thin fur. Again, it needs to stay cool. It's in the desert. Here, this Arctic fox, okay, it's very white, fluffy fur. Notice how they both blend into their backgrounds. Now these would have probably evolved over thousands of years. Now, you might get a question that says, these two foxes originated from the same species. Describe how the two species changed to be different. Let me see, I'm going to get better wording for this. Explain how the two different species of fox could have developed from a common ancestor. So there. Now, the answer for this will always be the same. The two ancestral populations, okay, so when they were both the same, they were all the same species, okay, you have to say the first point, they were separated. That could be by a river, it could be by a canyon, it could be by anything, okay, they were separated and they couldn't meet up again. Now, as time progressed, the animals that had the best characteristics to survive in that area would be favoured. For example, the animal that had the thinnest fur was more likely to survive in the desert. Can't spell desert. There we go. So, if this animal is more likely to survive, it is more likely to breed and pass the genes on. Okay? This keeps happening and happening and happening and happening for generations until eventually you have a new species. And when you have a new species, the important bit is that the new one cannot breed with the other species. So for example, the Arctic fox and the desert fox cannot breed with each other anymore. Okay? So this answer, again, is very simple. They were separated. This is the hardest bullet point here. This and this, you always say this. Okay, they're more likely to survive and breed and pass them on. I'm going to get survive out. Right. This bullet point, and this bullet point, you say every single time. Now, if you were talking about the Arctic fox, you could say the white fur made it more likely to not be seen by predators, so it was more likely to get food. So then it's more likely to survive and breed and pass genes on. Same answers every time. Now that you've listened to me ramble for a little bit, I would like you to have a go at these questions here. And notice they are going to be very, very similar. I've accidentally answered this one already. But this one here, instead of talking about foxes, you are talking about squirrels. So have a little read through and try and answer them. Once you've answered them, send me your answers either by email or by a picture or whatever you'd like.